Welcome back. So in the last video, we were looking at IP addresses. We looked at the classes of the IP addresses. We looked at private IP addresses. We looked at loopback addresses, local link. We looked at everything IP addresses. Now, today, we are going to look at something else called dynamic host configuration protocol. But before we get there, let me ask you a simple question. When you walk inside a building, and you connect your phone to the Wi-Fi, uh, you just usually you never even think about uh, how does my device get an IP address? How come I have an IP address? And the way we've been seeing, your device needs an IP address so that it can be able to communicate to other devices on the local area network and also be able to communicate to devices on the internet. But now, how come you never go into your phone settings and decide to put an IP address all the time, every time you connect to a Wi-Fi network or like connect your computer to, a hardwire? Why do you just not always go and put in a static IP address? We're going to look at what actually gives us this IP address so that we don't have to configure it manually. The protocol we're looking at today is a layer 7 protocol. It's called Dynamic Host Configuration Protocol. How does your device usually get an IP address? There are two ways that we usually give our devices IP addresses. So static IP, you manually type in the IP address. This is good for servers and devices that you need a fixed address on and you don't need that address to change. Let's say I have a server on my local area network and the IP address keeps on changing and changing and changing and changing. And our DNS, remember DNS is the domain name system. It resolves a name to our IP address. So if I'm looking for something like google.com, it will resolve that google.com to an IP address so that my computer can be able to understand the address, can be able to understand where I'm going. So imagine having DNS, like an example would be this: having to change the phone number. If you're on a phone and you're calling someone and they keep on changing their phone number every single day, you that's gonna be hard because how often, like, I'll be saving your number every single day. I'll be putting your number, like, let's say your name and then your number, a new number every single day. That's a lot of work. So that's like comparing it to a server. So with a server, because everyone is always trying to visit a server, is always trying, all the clients are always trying to get something from a server because it provides services. We want our server to have a consistent IP address. We want, if you're going to a restaurant, you want that restaurant to be at one specific place. Imagine if it kept on changing locations every single day. That's a lot of work. That's just too much. But anyway, with our clients now, we can always change the IP address of our clients because at the end of it all, it really doesn't matter. As in, our clients are the ones that are coming to the server to get the service. So the server does not need to cram every client's IP address, but the clients need to know the server's IP address. All right, so that's why with servers we give servers a static IP, and then clients we give them a dynamic IP. So we can use something called dynamic host configuration protocol. This is where we use a DHCP server to assign IP addresses to our devices. Imagine I'm in an organization and I have a lot of computers. Let's start here. Let's say I have 5 computers. That's okay. I can go to every computer, give it an IP address 192.168.1.0, subnet mask 255.255.0, write everything that I need to configure for the computer to work and communicate to the rest of the other computers. But now, let's increase that number to 10. Are you seeing the work is increasing? The work is too much. Okay, 10 is okay. I can handle that. 20, maybe I can handle that. 50, oh man, now human error. I'll confuse. Maybe I gave one of the computers IP address that ends in 20. I'm at my 50th computer. I'm giving it an IP address that is maybe 20 again. Errors, we start having issues. Just think about this. Imagine you're walking into a company. How many devices do you think are inside that company? Count all the computers that they have, printers, servers, all the phones that are walking in and connecting, all the TVs, everything, even if you have a fridge that has an IP address, all of them need IP addresses. And it will be just too much work for the network admin to go and give each device an IP address. So what do? We use something that assigns IP addresses automatically, and that is a DHCP server. When your device joins a network like a Wi-Fi, it needs an IP address to communicate. Instead of typing it manually, your device asks for one, and the DHCP server is like a receptionist. As you're walking into a building, they give you a visitor's badge that is temporary but lets you move around the building. And once you're done, you return that card to them and you're out. So I want us to do a lab where we'll be checking out how DHCP actually works. So what I'm going to do is I'm going to come down here, end devices, click on that. I'll pick some computers. I'm going to pick 3 computers on my network. And then I'll pick a server. So let's do one server. This will be our DHCP server. I'm going to move them into the middle so that it's easier to see. And then now I'm just going to rename this to DHCP server. And then for our DHCP server, because we've said with servers, we want to give them a static IP so that the devices, the clients, can know exactly where they're going. So 192.168.0.100. Subnet mask, of course, is a /24, so it's 255.255.255.0. I'll close out of this desktop. I'll come back to services. Since I want this computer to be a DHCP server, so services, after I click services, I'll come to DHCP. I'll come to service here, and then I'll turn it on. Now, I want you to notice something. It says start IP address. This is where we want our DHCP server to hand out IP addresses. Where do we want it to start? And what's the IP address? I'd want it to start at 10 all the way to 50. So I just only have 40 devices that I'm giving DHCP on this network. So let's do it. 192.168.0.10. That's where I want it to start. Of course, it will give our subnet mask 255.255.255.0. Maximum number of users, I want them to be 40 users, and then I'll just save. If you see this pool name, when it comes to pool, you're thinking of what is the range, like how many users do I want in this range, in this pool, you understand? So let's say the fact that I only want from 10 all the way to 50, that's 40 of them. So my pool is only 40. With the pool name, I can name it whatever I want to name it. I could actually name it like, fast 40 computers, something like that. I could name it whatever I want to name it. Right now, I'm just going to leave it in the default that's saying server pool. So server pool, that's the first pool that I've decided after I saved it. So you can see it will start. This is the starting IP. That's the subnet mask that it's going to hand out. The max number of users is 40. So I only have 40 computers having DHCP. All right. Now I can close out of this because I've already configured my DHCP. Let's continue with our network. So we're missing a switch. So let me come back down here to network devices and then click switches and then take a switch, drop it in there. I'm going to connect all my computers with a cable. So with an Ethernet cable. So let's just connect all of them with an Ethernet cable like that. Like that. Okay, everything is connected. Now, remember, the way we used to do this was we used to go to this computer and then come to desktop IP configuration. We used to check this static, and then we would come here and give it, we'd give it a static IP. But now, because we're doing DHCP, I want you to notice something. So I'm gonna wait for this lines to turn green first to just show that everything is online. Okay, cool. Now they're green. Now what I want to do is with this computer, I want to give it a DHCP address. So what I'll do, instead of clicking static, I'll just click DHCP, and then you see it's requesting, and just like that, I got an IP address 192.168.0.10, subnet mask 255.255.255.0. DHCP successful. Awesome. What just happened? That was like magic. As in, boom, boom, you get an IP address. We want to look at the DHCP process. This is something that is usually asked if you're doing a networking exam, or if for you just to understand. Maybe they could ask you this in an interview as an interview question. So what is the DHCP process? Let's go and look at what happened the moment I clicked DHCP on that computer and then it got that IP address.
DHCP has 4 steps: discover, offer, request, and acknowledge.
The acronym that we usually use is DORA, like Dora the Explorer. So DORA. Discover, offer, request,
and acknowledge.
I actually forgot to tell you what port and what transmission control protocol DHCP actually uses, because DHCP, of course, it's a layer 7 protocol, but it usually comes down to layer 4, our transport. You remember our transport layer is like the matatu that we are taking to go to different places. So DHCP usually uses UDP port 67 and 68. So up here, it's dynamic host configuration protocol. That's what gives out IP addresses. And we know our IP address is actually in layer 3 because this is where internet protocol address is. Are you seeing how all these things tie up together? This is literally how they tie up together. So DHCP hands out IP addresses, which is in layer 3, and it uses layer 4 protocol called UDP, User Datagram Protocol. We already looked at this. And the ports that I used over here is port 67 and port 68. Port 68 is what the client uses, and this is on our server computer. So if this was our client computer requesting for DHCP, our server is sitting out here. This DHCP would come in through port 67, and it would go out of our client through port 68. The IP address you get is often temporary and it's called a lease. It can expire and it gets renewed. So the IP address that you get from a DHCP is temporary because it keeps on changing. You know, the thing is, when you get this IP address, you are not here permanently, you know, as in you'll be here for some time and then probably your device will go offline. Some other devices come in and they also need IP addresses. So if my DHCP pool is only 40 users, sometimes I'll run out of IP addresses to give, right? That would mean if some devices go offline, of course, those IP addresses are taken back and given out to other computers so that also those computers can work. So that's why we're saying it's a lease. We give you a lease. We give you a DHCP lease, you know? And then it's temporary because we can take it back. Let's talk about the process now. Your client sends a discover. So it will send a discover from port 68. Hey, is there an IP address I can use? Then the DHCP server will say, hi, I have this IP available. So it will say like, I have this IP 192.168.0.1 available. And then your client now says, yes, please, give me that IP address. Once that has happened, then we have an acknowledgement from the server. So the server, boom, gives us the IP address. All set, you're good to go. Here's your IP address. That's literally it. That's what happened right here. And if we want to look at whatever just happened, let's switch to simulation mode as always. Simulation mode right there. And this time I'm going to click show all none, edit filters. I'm going to select DHCP. Once you click that, get out. And then now we can go to this computer PC5, which doesn't have an IP address. Let's go to desktop. Let's go to IP configuration. Click DHCP. When you click DHCP, see it's requesting right now. It's going through this process where the PC sends a discover. It's sending a discover. And then the DHCP server is going to give an offer. Here we go. So the first packet, let's open that packet and see.
As I mentioned,
DHCP is a layer 7 protocol. It uses layer 4 UDP. The source port is 68. That's the port of the computer, the client that's sending out the DHCP discover. And then it's going to enter the server on port 67, the DHCP server. That's where it's going to enter the server, okay?
On layer 3, notice our client is using an IP address 0.0.0.0 because our client is yet to receive an IP address. And this client is sending a packet to a broadcast address 255.255.255.255, which belongs to class E. If you don't remember about IPv4 address classes, please check the link above to view the video.
So this client is sending out a broadcast message to all these other computers on the local area network to try and find, who's the DHCP server. So that means all these computers will get this message. So let's keep on moving forward. It will send out a broadcast that goes and hits the switch. And if you also notice, the switch is also sending to a broadcast MAC. That's why we're seeing it's sending to a broadcast MAC right here, so that it can go to all the computers. Remember, I told you it's going to reach all the computers first. So, boom, it sends. Once it gets to those computers, because these two clients don't provide DHCP, because they don't provide that service, they are going to ignore that message. Once they ignore that message, the DHCP server, on this other hand, will accept, will say, yes, that's me. And it's now going to reply. So the DHCP server now, as you can see, it's replying from port 68 UDP, and it's replying to UDP port 67. It's also replying to a broadcast IP address. It's replying to a broadcast IP address because it also doesn't know, like this computer still doesn't have an IP address. So it's not like we're going to reply to it directly. So we're replying to a broadcast IP address. And if you see layer 2, our MAC is that, and it's also replying to a broadcast MAC address. All right. So once we reply like this switch will forward it to all the computers on the network, because we still don't know who was requesting this DHCP. So when we forward it to all the computers on the network, these two computers are going to ignore it. They're going to ignore because they never requested. But this computer, because it had sent out a discover, now it has been given an offer. This replied with an offer. So it gave it an offer. And as you can see right there now, inbound, it shows that the DHCP server, this is the IP address of the DHCP server, we remember. The destination address was a broadcast IP address, so it sent it to all the computers on the network. And even if you look at the MAC this is the MAC of the DHCP server, and this is the broadcast MAC for all the computers. Anyway, as it replies, let's go ahead and see what is inbound. So it replies, and you can see the message right here. It's saying your client address, this 192.168.0.11. So this is where we are. We are literally at this. It has given an offer. I have an IP address. This IP address is available. So that's the IP address that's available, 192.168.0.11.
Now that we've seen the offer from the DHCP server, the client is now going to send out a request.
It's going to send out an outbound requesting to be given that IP address, because it doesn't have an IP address, all right? So as we look at the OSI model, we see that our client is also sending another message through port 68 to port 67, the DHCP server on that other side. But it's still sending it to our broadcast IP. Forward it to the switch, and then the switch sends a broadcast again. These ones will still ignore it because it doesn't concern them, but the DHCP server will take it. And once it has taken it,
it will reply acknowledging that it has assigned that IP address to that client.
Inbound, this came from this computer saying, okay, cool, you can give me that IP address. And then now this one is going to reply and actually give it that IP address. You understand? Okay, so let's keep on going. As it replies, it hits the switch. And then now that was still a broadcast, because this one still doesn't have an IP address. So we're just still sending broadcast messages, all right? And then now, as it reaches this computer, this one accepts it. And you can see now it came from that. It went to a broadcast address, and now it has arrived here. Let's see if this computer now has an IP address. There we go. So this computer now has an IP address, and DHCP request was successful. And that's how you get DHCP, definitely. That's how our computers usually get IP addresses. Now, if you want to see the DHCP on your computer, live computer, let's see, CMD. I also want to open Wireshark so that we can see live it happening in real life. So my CMD just opened, and then my Wireshark just opened. So first things first, let's see what our DHCP server is. So I'm gonna do ipconfig/all. Here's my DHCP server, you see?
I want to show you something. Remember when I mentioned that the IP address is temporary? That means it's on a lease. It can expire and get renewed. So what I want to do right now is I want to release the IP address that I got from my DHCP server and renew to get another IP address. That means I'm renewing my lease. You understand? So let's open Wireshark in the background and capture the packet as this process is happening. I've just selected Wi-Fi because that's the network adapter that I'm using right now. I'll do an IP release. This releases the IP address that my computer already had. And then I'll do an IP renew to get a new IP address from the DHCP server. You can see that I get a new IP address from the DHCP server. I'll then filter out the traffic that's being collected on WireGuard to view only DHCP traffic. And as we are viewing DHCP traffic, you can see the first line, I had done an IP release to remove the IP address that I had. But also after I removed the IP address, I got a new IP address from the DHCP server by doing IP renew. So this is why you are seeing the whole DORA process on the right, the DHCP process: discover, offer, request, and acknowledge. On the left, you can see that the client sent a broadcast to an IP address 255.255.255, and then you can see the DHCP server IP, and also you can see the IP that the DHCP server gave to my laptop, which is the client. And if you just look at this, this is exactly what I just explained in Packet Tracer. So Wireshark just captures whatever is happening on the network, and yeah, you should download it and learn more about Wireshark. To finish off on the topic of DHCP, I had mentioned in the previous video that if your computer doesn't get an IP address, you end up getting a link local address, and that means that your computer becomes an island and it cannot communicate to other computers on the network or even outside to the internet. So if your computer fails to get a DHCP, and maybe there's a problem with the server, or maybe there's a problem with your computer requesting for DHCP, you end up getting an address like this, link local address, and then you end up not having internet.
I hope you found that video interesting and informative. If you have any questions, remember to write them in the comments or just reach out directly to me, and I'll be able to answer you. See you next time. Peace.